At the end of this topic, you will be able to compute the sum of n terms of a GP, compute the sum to infinity of an infinite geometric progression.
Sum to n terms of GP. Let Sn be the sum to n terms of a GP with first term a and common ratio r. Then Sn is equal to a plus ar plus ar squared plus ar cube and so on plus ar to the power n minus 2 plus ar to the power n minus 1. Equation 1. Multiplying both sides by r, we get Sn is equal to ar plus ar squared plus ar cube and so on plus ar to the power n minus 1 plus ar to the power n. Equation 2. Subtracting equation 2 from equation 1, we get 1 minus r into Sn is equal to a into 1 minus r to the power n, which implies Sn is equal to a into 1 minus r to the power n by 1 minus r.
Let us now view the formula for the sum to n terms of a GP for some special cases. Case 1. Given r is equal to 1. When r is equal to 1, the sequence reduces to a constant sequence a, and so on, and Sn is equal to n into a. Case 2. Given r is less than 0. If r is less than 0, then Sn is equal to a into 1 minus r to the power n divided by 1 minus r. Case 3. Given r is equal to 0. If r is equal to 0, then Sn is equal to a. Case 4. Given r is greater than 0. If r is greater than 0, then Sn is equal to a into r to the power n minus 1 divided by r minus 1. Case 5. Given L, the last term, if L be the nth term, then L is equal to a into r to the power n minus 1, and so Sn is equal to a minus L divided by 1 minus r. This can also be written as Sn is equal to Lr minus a divided by r minus 1. Let us learn about infinite geometric progressions. We will consider the case when the modulus of r is less than 1. Consider the GP 1, 2 by 3, 4 by 9, 8 by 27, and so on. On calculating, we find that Sn is equal to 3 minus 3 into 2 by 3 to the power n. We observe that Sn becomes smaller and smaller and approaches 0 as n becomes larger and larger. Thus, if the modulus of r is less than 1, then r to the power n tends to 0 as n becomes larger. Sum to n terms. Infinite geometric progressions. For a GP with the first term a and common ratio r, the sum of n terms is Sn is equal to a into 1 minus r to the power n divided by 1 minus r, which is equal to a divided by 1 minus r minus a into r to the power n divided by 1 minus r. If the modulus of r is less than 1, then r to the power n tends to 0, and so a into r to the power n divided by 1 minus r tends to 0. Hence, Sn is equal to a divided by 1 minus r. Thus, the sum to infinity of a GP with the modulus of r less than 1 is given by S infinity is equal to A divided by 1 minus R, where S infinity denotes the sum to infinity.